Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility, so this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows. Dave, could you kick us off and tell us what happened in this event?
Okay, I'd be happy to do so. Let me start by acknowledging that this was a major incident. We absolutely did not live up to our aspirations to provide a reliable platform on which our customers can base their services. In my 13 years of running production networks for Microsoft, this was by far the worst outage that we've had. We've done a lot of deep digging to understand how it happened, and Eric and I will be telling you about those details as well as the repair items we have to keep this kind of thing from ever happening again. The issue started with a normal day, as it often does. We had a network engineer, who was adding 2 new routers into service in Madrid as part of increasing the capacity of our global wide area network. When an engineer is making a change to the network, they follow a method of procedure. We call it a MOP. Now, in this case, this is a MOP to change the IP addresses associated with those routers before they get added in to take production traffic. This is a MOP that has been used many, many times. However, in this case, the engineer responded first to some feedback they had gotten from a previous run of this MOP, where they found that the router was left in a state that they thought was inconsistent. So the engineer added a new command to the MOP that would clear up this inconsistency. When the engineer ran this MOP on the router in Madrid, that new command had a very unexpected impact. It had the impact of telling not just that one router to change its state, but caused that router to send out packets to all the other routers in the wide area network, telling them to clear what we call their interior gateway protocol database, basically telling them to forget what they knew about their neighbors and start relearning all of that information from scratch. The result of this is almost immediately after the engineer ran that command, our wide area network started to lose the ability to carry packets between the many different endpoints that it connects together. Now, as soon as that engineer ran the command, our network is designed for resilience and to bring itself back into health, and so it started recovering itself. However, given the size and scale of our network, it takes those routers quite a bit of time, up to 1 hour and 40 minutes, to relearn and rebuild all the information that they normally hold. There's an additional aspect here. Because of the change that was made to this method of procedure, the engineer was not notified of the global impact that occurred to the WAN. So even though our monitoring and alerts went off within 5 minutes of the impact starting, and our on-call engineers were joining on bridges to figure out what was going on and how to recover, that engineer continued on with their day, making the exact same change to a second router in Madrid, thereby restarting the learning process called reconvergence all over again and delaying the length of the impact. Now, this is not how changes are supposed to happen inside of our network. Normally, every change that's made to the network by a human being goes through at least a 4-step process. First, the entire method of procedure is written out, exactly what the engineer is going to run on each routers, and it's tested against what we call the Open Network Emulator, or WAN. That Open Network Emulator has an exact reproduction of our entire wide area network, all the software that runs on all the routers, all the configuration that runs on those routers, and it runs not on real hardware, but on top of virtual machines hosted in Azure. By doing this, we're able to predict, will this method of procedure cause a problem or not? The second normal step in a rollout is that method of procedure then goes to peer review. It's reviewed by senior engineers on our team who make sure the method of procedure has all the right precondition checks and post-condition checks to make sure that the situation is safe when we start and the network is safe and healthy when we end. The third step is then a safe fly. Even after peer review, then executives, my directs, myself or my directs, have to review that change again to make sure that it meets all of our criteria and that we have appropriate rollout, rollback, and monitoring steps that are part of it. The fourth thing that happens is what we call safe deployment. In the case of the wide area network, our engineers are allowed to make a change to only a single device at a time. And we've taken steps through our AAA system that verifies each command to run on the router to make sure that only commands that are going to have an effect on a single router are run. Another challenge we ran in this case is that our wide area network does consist of routers from 3 different vendors, each running their own vendor operating system. In this case, the command that the engineer added to their method of procedure does have a local effect on 2 of the 3 types of routers that we use in our wide area network. On one type of router, however, the command has this different unexpected behavior of actually sending out packets globally across the network and telling other routers to make a change in their state. This is something that we normally catch as we're onboarding new routers into our network. We do an extensive validation and qualification process that then builds this list of allowed commands and block commands that is fed to our AAA system. The change in semantics on this particular command was missed as part of our onboard qualification process, which is why this command was allowed to be run. The result of this impact was that different parts of the things connected to the Microsoft network started losing connectivity at about 7:08 UTC. There was a second wave of impact beginning about 7:40 UTC when the command was run a second time. The network, as I said, was already in the process of rehealing itself as it's designed to do. And so connectivity came back on for different parts of the regions and different endpoints over the period between when the commands were run and about 9:25 UTC, when all of the network devices had completely rebuilt their information, were healthy again. We did see that there was additional packet loss in some portions of our network for a period of time after all the routers were recovered. This is because we use automation systems to watch the routers and paths in our network to make sure that those routers and links are healthy and the traffic's following the most optimal process. As part of this large wide area network impact, we paused those health systems. And until those health systems were restarted and brought all the network devices back into healthy, there were some paths, particularly in the India regions and in North America around Chicago, that saw additional packet loss. The network was fully recovered and performing optimally by 12:35 UTC. We understand that there was additional impact to many of our customers who depend on the services that run over this network, as those services often require time to recover after this major global impact to their ability to connect with each other. This is something that we don't expect ever to happen. It clearly did, and Erica will now tell us about the repair items that we're doing to keep it from happening again.
Yeah, I think just as Dave said that this incident definitely is unexpected, but I think if I step back, we try to find, the repair item. One kind of the pivot is what makes the intent and the reality drift, right? What's it? We have all the good intent. We built all this tooling system in the engineering pipeline, and we do a lot of the simulation, emulation of our system whenever there's a change, no matter is the configuration change or the physical world have fiber cut, have router fault. But why this still happen? I think after we kind of reflect, so we have listed the repair item. The immediate one we already published in the public PIR. I think again, go back to this, why the drift between the intent and the reality. So the first intent is we don't want to allow the design or the intent is no command which can change the configuration of a remote router, only limited with a router, and then rely on the network protocol to propagate the change gracefully. So that's the intent. And then the drift from the reality is that the unqualified command, which they've already explained, unfortunately, different router vendor has a different behavior, actually have changed the configuration in the remote router. So the first thing we did is we want to do in the process is to block all the command, which that's our intent. And then the second thing is about the quick, fast detection. So we audit, all the real-time behavior, as well as to double review, which already the intents already happened, the reality also happened, but we want to make sure that we are self-critical to further find out why this drift can happen. So we review all those maps, or and just as Dave described. The next thing is about training. We reflect back ourselves. We have many new hires, and we give the training. We looked at. We have a lot of lab, hands-on engineering pipeline, system education, and then we ask ourselves why this still happen, and we find that the training so much focus on how the engineering pipeline work, how you should use that. But one thing is very important for me is to really remove that judgment call, because people actually very talented. They have experience from different places, and we hire very good talent from different places. But in Microsoft network, I think we have one of the largest WAN connect all the 70 regions and 130 POPs and petabyte kind the capacity. We really need to have this mindset, be humble and respect the network. Really cannot be calculate or simulate in your brain based on previous experience. So that's the training about, not just only about tooling, but also about mindset a bit, but also about this be humble in front of this large network. We are very honored, privileged to run this large network. At the same time, it's also the huge liability. So that's the training part we want to cover as well.
Super. Thank you very much, David and Erica. David and I are collecting feedback from customers in various places. When customers registered for this event, they would have had an opportunity to ask questions. And then when we post our PIR, like we did a week ago, customers then would have been able to provide feedback. And so we've been gathering questions from those places.
And remember, we're also running the live Q&A during the sessions. We'll be keeping an eye on kind of the most asked questions to bubble those up. Should we get into it?
Absolutely. So Dave, in reading the PIR, some customers were surprised to learn that the minute we found out what was going on, and you mentioned it as well, the network started to heal itself. Could you talk a little bit about that? If humans had never got involved at all, would we have just been kind of on our way to goodness, or?
Hey, that's a great question. And the answer is yes. So we design our network with multiple layers of automation inside the network devices. They're called routing protocols that the routers speak to each other. And we've designed that in a resilient way. So essentially, if the network is perturbed, it already starts working to heal itself and regain connectivity between all the points in it. So yes, in this issue, our network engineers did not have to do anything to actually bring the network back to health. The only thing our network engineers had to do was restart our automatic systems that run on top of that network to look for devices that need to be sick or that optimize the flow of traffic through the network.
Great, that makes sense. There was a comment in the post-incident review that was talking about impact to Azure government and how the Azure government could be impacted by this. Reading through some of the feedback, it sounds like that surprised some people. So could you explain, obviously that the government cloud is separate from the public cloud, but we mentioned there are some interdependencies when it comes to the network?
Okay, absolutely. So Microsoft does operate multiple clouds. We operate what we call our Azure Commercial Cloud, on which hosts many third parties. We do operate an entirely separate cloud called the Azure Government Cloud. This hosts many services that are used by parts of the US government. We additionally host other clouds that are completely air-gapped away for secret and top secret offerings. In this case, the impact of the wide area network outage did impact both the Azure Commercial Cloud and the Azure Government Cloud, although not our air-gapped clouds. The Azure Government Cloud was impacted in the following ways. It gets its internet connectivity through the Azure Commercial WAN. Although it is its own self-contained network, it has its own wide area network that connects it inside of itself, the different regions that make up the Azure Government Cloud. When those regions need to communicate out to the internet, they do so through our commercial WAN. So customers with services inside the our government cloud would have seen impact if those services needed to connect to clients or other services out on the internet, or if they were connecting to services hosted inside the Azure Commercial Cloud, because that again goes across the commercial WAN.
Super, thank you. Eric, I have a question here. Usually when when following an outage, we'll talk about customer resilience and things customers can do to prevent impact. Given the scale and the breadth of this outage, I presume was there anything customers could have done? I presume there was nothing customers could have done in terms of architecture to be immune to this type of event?
Yeah, you're right. I think, unfortunately, fortunately, we take hold responsibility. I think that just as Dave described, when this unqualified command be issued, have an impact, the widespread impact, which we don't expect. And the network protocol actually pick up and self-recover. And actually, during the incident, I mean, just as Dave described, we have this emulator to give people kind of understand we are very, very serious about this emulator. We actually take 20,000 cores of Azure in Azure to emulate our wide area network. The spend is 60K to 20,000K per month. So thanks, Dave, to pay the money. So we are actually every command we want to go through that. So that's because we know how significant or how important to match the intent and reality. So we make that investment. And so go back to your point, yes. Then we rely on the underneath protocol to propagate the change and then gracefully recover. However, one thing I do want to say that in the physical world, things evolve. And then we do expect fiber cut, we do expect the router fall, we even expect site down. And then we do all the simulation, emulation, so that the network can be stable, even with those events. But the network continue evolve, not just because of scale, the growth, and also customer have the requirement also evolve. And we also want to take the new technology to benefit our customer, to have the best connectivity. So we do continue tuning our network and then to optimize. I mean, just as Dave say, we have the system to optimize the connectivity and even after this event. So all these are together. So it's really on our side to learning from this event, this kind of like a stress test, and then to continue involved. Yeah, yeah. Dave have something to add.
Yeah, can I add on to that answer?
Yeah.
So again, Azure as this platform is designed for resilience. And so we have multiple regions, and we've talked in the past how we have safe deployment practice that changes are only made to one region at a time. And inside of each region, there are multiple availability zones. Changes, again, made to only one availability zone at a time. And even in this incident, connectivity inside of the regions was unimpacted. Availability zones could talk to each other. We had full availability there. Unfortunately, what was impacted was the wide area network that connects the regions together and connects those regions out to clients on the internet. So this is one of those horrible accidents, horrible incidents, where I can't offer customers a mitigation approach. I don't know that what customers could have done to design their services to be able to maintain availability during this wide area network impact. So Eric and I understand that, and that's why we have all this investment that we made in fully validating every change that goes to the network. It's why we make the investments in the Open Network Emulator, because we understand that the wide area network can never go down. So our goal is not quick recovery, it's never having impact in the first place.
Oh, that's really helpful. I'm having a look at, there are some customers talking about, in the PIR, this is probably a question for you, Dave, that we were talking about blocking these impactful commands. And customers who are running their own networks out there were asking how we classify these commands as impactful versus not. Could you help us to understand kind of how we categorize that? And maybe that will help them inform their own allow list, block lists for their own commands.
Okay, that's great. The first thing I actually should say that I didn't say during my initial update was that our goal is to have no human logging into routers ever. The vast majority of changes made to our network are actually made by automation, by engineers who have coded up those changes and are running them on one of 2 approved platforms, which essentially automates the process of making sure the network is healthy, applying the change step by step, and then verifying after each step that the network remains healthy. There are a class of method of procedures that our engineers still do interact with devices over the command line interface. And we're in the process of taking all of those and getting them automated as well. But they tend to be the ones that are used in these sort of non-standard situations like build out or adding capacity to a device. Now, as Erica said, a requirement for a dangerous command is one that has any effect off that one router. Again, our belief is that by saying that an engineer can make a change to only one device at a time, and the changes they make can only impact that one device at a time, we can then use the redundancy that exists inside of our network to keep the network as a whole safe. Because if one device fails, that's not a problem. We have many other redundant paths that are able to pick up the traffic. In fact, everything we've designed in our network is so that we fail safe. If a device or a link is looking like it's not working properly, we turn it off, we take it out of service, and then we can troubleshoot it later. As soon as we turn off anything that looks problematic, the network itself will recover around that and restore connectivity. So whenever we're finding the commands that need to be on that block list, it's any command that's going to have impact off of that single device.
Great, super, thank you. I have a question from to Erica maybe. Customers are interested to know a little bit more about how impact was felt. We spoke about multiple services and multiple regions being impacted. Were the failures persistent? Were they intermittent? Were some regions more hard hit than other regions? This was going on in Spain and Madrid. Was that the focal area or was it the whole WAN?
Yeah, I think the impact is the whole WAN, because we kind of rebuild this routing routes and then across the globe. And it's indeed, I mean, the speed of recovery have different variables. And I think it's hard to really commit in anything, but I want to give a little bit, the concept is that it really depends on when you get on our network. And then, and from that point, how you get to the access. So distance or across region, and all those are impacted. We actually, in our internal monitoring, we see that most of the region to region are not impacted, but region to internet to region impact immediately. But then during the recover optimization and time, then there's a period of time of the long tail instability. So in the past 2 weeks, customer calls, we have people ask the question. Some people see early recovery, then the time we publish. Some people see that even the end time is correct, but they see that even we say the network, most of the network recover, why they still have impact. And yesterday, we even had one customer tell us they don't see impact. Yeah, so I think it really depends on the topology and also network partition, as well as the application and the workload. So there's no simple formula to predict that. Yeah.
Great. That makes a lot of sense. Dave, question for you. There are some people talking about the repair items in the post-incident review, and we said, for example, some of those were going to be implemented by the end of the month, by the end of February. And so they've asked, is that to say that we're not doing maintenance, we're not making changes until those repair items have been put in place, or are there specific things that we're kind of avoiding for now until we have those repairs in place? Could you help us to understand that?
Sure. So we have certainly dramatically reduced the scope of changes happening to our wide area network to go back to the minimum required to maintain the health of the network while we're in the process of doing those repairs. As you can see in that post-incident report, we've got the repairs staged out, the most critical ones happening right now. We're working on those 24/7. Azure is a global team, so we have folks working on these around the clock from all of our different locations around the world. and we're concentrating on making those most critical repairs first and making sure that changes that are still happening to the network are going to be safe.
Got it. Yep, that makes a lot of sense. Sammy, anything for our networking engineers? Otherwise, I've got a question about comms. I can turn the table on you.
I'm more than happy to answer, David.
Well, we're talking a little bit here about kind of how the communications were distributed during the event, and I know we were communicating both on the public status page and in portal to Azure Service Health. But here, seeing a couple of customers talking about some delays with their in portal notifications. Could you just talk a little bit about kind of how we communicate during the incident and why customers might not have been told about this straight away?
Absolutely. So for the most part, our customers, for most of our outages, we have automatic notifications. So notifications go out within 15 minutes and targeted to impacted customers. There are scenarios that are not covered there that we're investing in, and we'll continue to invest in those. When we received signal for this WAN outage, it was widespread, and it wasn't very clear in the beginning. And so we prioritized getting broad communications out on our public status page. And while we continue to investigate and understand the scope of impact, that it was a global outage, we then proceeded to send targeted notifications. It wasn't a successful story with communications. We were delayed. We acknowledged the delay, and absolutely we're taking repair items to make that better.
Great, I'm glad to hear that. There's also, while I'm asking you questions, there's also another one here talking about the alerting systems that we use. So if a customer configures a service health alert, fire off an email, fire off a text, something like that, if Azure's having issues, if the WAN is having issues, do those alerts still go out? How does that work?
There are two things to consider. We've had outages in the past where some of our comms channels have been impacted. For example, some people could not get to our public status page. Other times, customers may not be able to log into the portal to go through Service Health and look at the UX there. Our Service Health notifications are on dial tone infrastructure, which means even when Azure is suffering, those alerts will still fire. Now, for customers who had signed up for email, we know that Outlook and Exchange may have been impacted. But for customers using the webhook in particular, those notifications will flow through, and they'll be unimpeded by any Azure outage.
Great to hear. Keep an eye on the time here. We're going into the last couple of minutes. Anything you'd like to end with? Any final comments from you, Dave or Erica?
Well, again, we understand the seriousness of this incident, the impact that it's had on your business and your customers. You have our full commitment to make sure this doesn't happen again. As you've heard, we've put many layers of resiliency and redundancy into Azure, and we're continuing to put guardrails around them to make sure that those function as we design them.
Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too, and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage, and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.
Thanks.